Good morning, everyone. I feel like it's been ages since I've seen you. I miss you guys. I hope everyone is staying healthy and doing well. There are a few of you that are having me a little worried because you're a little MIA and I haven't seen any homework from you. I hope you are healthy. I hope you have not lost your mind yet, and I hope your family is healthy. I've been praying for everybody. So let's continue on this week with our work with logarithms. Hopefully you had a good understanding from what we did. I'm going to finish up looking at some of the properties of logs today. And then tomorrow later this week, we are going to do a quiz. Joey wants some milk. Oh, there's Riley in the corner. You see her? All right, I thought I could do a video without them, but I've got to go get milk. Ah! There she is. Oh, and I'm sorry that sometimes my videos are posted a little late. Ryan's doing his homeschooling now, and both kids are doing their therapy through teletherapy. So, as you can see, my life's a little crazy, and I do my best. Love you guys. Bye. Okay, so today what we're going to be looking at is a continuation of the logarithms and what you guys saw during my last lesson on a video. Now, this first property I actually mentioned in the last video, but I do want to go over it again. Now, this first property is log base b of b. Now, I told you guys when you see something that looks like this in this example here, log base 3 of 3, well, I told you it means 3 to what power equals 3. Well, when these are the same, this is always going to be 1. Now, what some people will do when they're trying to figure these out is they'll also set it equal to some variable. And by setting it equal to some variable, then they'll switch it to exponential form. So we have 5 to the x equals 5. Well, we know that this 5 would have an exponent of 1, so this would then be 1. So, log base a to b, that's going to be 1. But then we get to this problem, log base 4 of negative 4. Now, this negative 4 and the 4, those are not identical. They're opposites. But the reason I come to this one is some people on their homework from last time wrote undefined, but I didn't know how you do that other than looking at the answer. So one thing that you guys need to know is that this is, in fact, undefined. And so one important thing for you guys to know is when we're looking at this whole log base b of y equals x, these two numbers will always end up having to be positive. You can't take the log of a negative or of 0. And it goes back to the graphs of the exponentials. So the reason that I can't do that is because we know that this question is saying 4 to what power equals negative 4. But the graph of my function 4 to the x looks like this. And so you guys can see that it never falls below the x-axis. So my values of y are never a negative. So the truth is that this negative 4 doesn't even exist on the graph, and that's why it's undefined. But you just need to know, can't take the log of a negative. If you have that scenario, then all you're going to want to do is write undefined. All right, so now we get to property number 2. Log base b of 1 equals something. So let's take a look here. Now, if I set this equal to x, and I changed it to exponential form, I have 1/2 to the x equals 1. Here, 9 to the x equals And, well, 4 to the x equals 1. Well, the only number that could possibly make all of these equal 1 would be if x equals 0. Because any number raised to the 0 power will always equal 1. So whenever you guys see log base b of 1, that's always going to equal 0. And knowing these is going to make doing some of the other problems later on way easier for you. Okay, so then the last property that I want to look at looks like this. Log base 2 of 2 to the third, what is this going to equal? Well, there's a few ways to go about doing this, but I'm going to do the same thing I did before. I'm going to set it equal to x. And I'm going to go ahead and I'm going to rewrite it in exponential form. So I have 2 to the x equals 2 to the third. Well, looking at it like this, well, it's kind of obvious now. X equals 3. So in this next problem, it's not in the same form as that third property or the same form of this one. But I can rewrite it like that. I can rewrite 1/5 so its base is 5, just like the base of the log. So that becomes log base 5 of 5. Log base 5 of 5 to the negative 1 equals, well, now I can set it equal to x, and you guys will see 5 to the x equals 5 to the negative 1, so x equals negative 1. And last but not least, this last one I can write log base 3 of 81. Well, I can rewrite 81 as a power of 3. Well, that's log base 3 of 3 to the 4th power. Well, 3 to what power is 3 to the 4th? And in this case, well, 3 to what power gets us to 3 to the 4th? Well, it's going to be 4. So whenever you guys are looking at this problem and you see that these two match and you've got this exponent here, well, that's always going to equal whatever the exponent is. And this last one. Like this last one, you'll see it occasionally. Not very often. But when we go to this last property here, I'm only going to give you like one example, 1 or 2. If I gave you guys 2 log base 2 of 8, and I asked you to evaluate this. I know it looks weird because right now there is a logarithm in it, but this is actually an exponential form. Okay, so we end up with, if I set this equal to x and then I change it to logarithmic form, I end up with log base 2 of x equals my exponent, which was log base 2 of 8. Well, in order for that statement to be true, that means it's enough, Joe, that this is going to end up equaling x. But like I said, out of all of the properties, that this is like the least used. So, 2 more problems. All right, here we go. Yeah, it's more of a doozy, isn't it? But what you guys want to do when you're dealing with these is just go term by term. And I'm going to rewrite all of these using these properties as best I can. So, right now, I have my 3 here and then my 27. Well, this means 3 to what power is 27? 3 to what power is 27? So the answer is 3. So that whole thing equals 3. Then I'm going to bring down my minus. And then I have a 4 as a coefficient. So I have 4 times. Now, log base 2 of 1/4. Can we rewrite 1/4 so its base is 2? Yeah, this could become log base 2 of 2 to the negative 2. Because 1/4 is 1 over 2 squared, and if I move it up, it becomes 2 to the negative 2. So this then follows this third property so that the entire thing is going to equal negative 2. So I have 3 minus 4 times negative 2. Now I have log base 9 over 1. 9 to what power gets me to 1? 0. Alright, now we have to follow our order of operations, and we know that we're going to have to multiply first. Oh, thank you, but see, Joey's offering me a pizza. Joey, watch out for Riley. Joey's offering me a pizza-flavored goldfish. I'm kind of a cheddar girl myself. I'm good. Okay, thank you though. So, when we go to do our order of operations, negative minus 4 times negative 2, so we end up with 3 plus 8 plus 0, which is 11. Nice job, folks, if you're still watching, because most of you only watch half of the videos. Alright. It's true, Joey. I've seen the data. Okay. Now, so let's look at this one. So last time I saw you guys, I was like, okay, so 5 to what power gets us to 1 over 125? 5 to what power gets us to 1 over 125? And the answer, everybody, the answer is negative 3. Okay, so I have 3 times negative 3 times the quantity of log base 7 of 7. 7 to what power gets us to 7? And that looks like property number 1. So that gets us to 1. Not because it's property 1, but just because those match. Plus 2 times log base 9 of 81. Log base 9 of 81 means 9 to what power gets us to 81? 9 to what power gets us to 81? That answer is 2, folks. So again, now we need to look at our order of operations. 3 times negative 3. Negative 9 times 1 plus 4, which is 5, equals negative 45. Okay. Now, I am going to post a few problems for homework. Give them a shot, check your answers, submit them where I tell you to submit them, and carry on, folks. I'll see you next time. Say bye, Joey. Joey, say bye.